Hi guys, welcome to another episode of MrLopezClass.com. This is the chapter 7 about our book of corrosion systems, marine corrosion systems. In this chapter we are going to analyze the different type of corrosion. This is, in my opinion, a summary of all the theory learned until today about the consequence, why the corrosion is produced, the factors that affect the corrosion. And in this chapter we are going to put the name of each type of corrosion. But at the end of the day, all of them are because the same factors, and the consequence in all of them are exactly the same. This is basically nomenclature about the name of each type of corrosion. Until this moment, it's clear that the environment, the humidity, the amount of moisture in the environment affect the corrosion. The type of environment, environments with a high salinity, environments with a high alkalinity, environments with too much acidity, the pollution, the ozone close to the atmosphere, to the surface of the earth. The environment affects highly the phenomenon of corrosion. The second one is the type of materials selected in the fabrication of boats. This is vital, this is important. What type of alloy, what type of materials. And also the combination between metals when you need to put metals together. In what cases you need to put metals together? When you need to install a piece of metal with bolts, with rivets, with when you need fixed brackets, when you need bolted one piece into the other one, in that moment you put a couple of metals together. This is other important factor. The materials, and now if those elements selected are appropriated according with the location in the periodic table, according with the difference in electronegativities, and additionally if is humidity in between both of them, that's not good. And additionally if you have a leaks of current, or a current is passing through those metals, the similar metals, those factors affect the corrosion highly. Now, after this chapter, we are going to analyze the different type of codes, the different type of protections used in order to avoid the phenomenon of corrosion, and what type of protections, what type of codes are appropriated for marine environments, and what type of codes are appropriated depending of the hull of the boat, and depending of the type of water, and depending of the material. All right, we are going to start checking the different type of corrosion. There are different names, but once again, at the end, all of them are the same. It's a different name, but corrosion is corrosion. Doesn't matter if it is in impingement corrosion, or if it is crevice corrosion, or if it is galvanic or electrolytic. This is corrosion, and at the end of the day, the metals are corroded and eroded and destroyed. Erosion corrosion. We are going to study one per one, and we are going to analyze one per one. Erosion corrosion is basically impingement corrosion. And now we are going to check what is the meaning of that. Crevice corrosion is basically when you have a stagnant solution over the metal. Now we are going to analyze. Poultice corrosion. Poultice corrosion is basically dirt, debris, humidity over the surface. The secret is keep clean the areas. Pitting corrosion, like a drill. Pitting corrosion is a localized form of corrosion producing cavities, holes. Galvanic corrosion is an electromechanic process in which one metal corrodes the other one. The more noble metal corrodes the less noble. Intergranular corrosion is the corrosion, I explained some chapter before, in the neighbor especially when you have a welding area in that neighbor area. That type of corrosion is intergranular corrosion. Yes, yes, those are basically the most common type of corrosion. Don't forget that we are going to start with galvanic corrosion. You remember what is galvanic corrosion quickly? It's the corrosion because you have two dissimilar metals together in a marine environment. Yeah, when you have two dissimilar metals, you have two different levels of energy, two different potentials of energy together, mixed in a marine environment. Oh, when you have two dissimilar metals touching one the other one, the more noble attack the less noble. Yes, it's basically because the potential difference, because the polarization, because one become a cathode and the other one become the anode. Yeah, this is the reason for galvanic corrosion, and there are a lot of factors that accelerate the galvanic corrosion. If you use copper alloys, what type of copper alloys? If you use iron and steel, what type of iron, what type of steel? Is stainless steel? Is the appropriate stainless steel? Is marine grade stainless steel? The stainless steel we are going to use. Lead. Lead is good to storage, but it's not good to combine. All right, lead is normally used like a lubricant in some alloys. Nickel alloys, zinc alloys, and depending on the alloy, depending on the combination, the galvanic corrosion will be accelerated. Electrolytic corrosion. Yes, electrolytic corrosion is basically galvanic corrosion. This is basically galvanic corrosion plus current. This is electrolytic corrosion. Yes, when you have two dissimilar metals together and additionally a leak of current pass through those metals, finito. Yes, normally what is the current that pass through those metals? Is DC current. Yes, my friend, because it's the current that is stored in the metal and is drained. Oh, if I have a short because at the hotline of one AC cable touch the metal, that current is drained immediately and finished. But you don't have a constant flow of AC current, because when you have a short, the hotline touch the ground, immediately the current is drained, but the breaker is out and no more flow. Okay, but for a couple of seconds, milliseconds, you have a big current flowing, but it's for a short period of time. Constantly, you don't have AC current passing through the block of the engine. It's clear? When the hotline touch the metal, immediately goes to drain, and the breaker, because the intensity in the breaker increase, and open the breaker. Alright? For that reason, if you have a situation with a constant current flowing, that current should be DC. For that reason, the analysis is focused in the DC area. Yeah, if you have shorts, once again, that current is drained, but is faster. The AC current, the motors in movement, produce too much static electricity accumulated on the metals. That's different. But produce DC, the static electricity at the end, the storage electricity is DC. Okay, for that reason, it's critical the bonding. For that reason, yes, AC and DC, both of them produce. For that reason, it's critical the installation of the galvanic isolator and the isolator transformer and the grounds, good grounds. Be careful with the battery chargers and the inverters. Use marine battery chargers, marine inverters, because those equipments are isolated from the beginning inside, are designed for marine environments. If those elements, battery chargers and inverters, are metallic, the case of those elements should be connected to the AC ground bus bar. AC ground bus bar, ABYC question. Okay, my friends. This is in case of the electrolytic corrosion. And once again, the seawater, the marine environment affect a lot the corrosion. Let me show something, shows some important information. Why the marine environment is important. Don't forget, my friends, try to keep in mind the periodic table. And try to remember that the elements located in this corner, all of those, they accelerate the phenomenon of corrosion a lot. We have fluorine, we have oxygen, chlorine, sulfur, phosphorus, nitrous, bromium, but basically those fluorine, chlorine, sulfur, oxide, and nitrous, and phosphorus, they affect the corrosion a lot, they accelerate. Look at this slide related with the composition of the seawater. The seawater, 55% is chlorine. 55% is chloride. Half of the seawater is chlorine. For that reason, the seawater is highly corrosive. A lot of chlorine attack. You know what happened with chlorine. It's the highest electronegativity in the periodic table. Only 7 electrons in the last orbit. Chlorine only needs one more. For that reason, is looking for one extra electron all the time. Bromium, other element located here in the periodic table. This is bromium. This is bromium. Once again, group number 7. One electron, need one additional electron to be stable. Attack everything. Look, bromium is 0.2%. 0.2% lose a little bit, but it's a lot. Sulfur oxide, practically 8%. Sulfur oxide, a lot. And fluorine, magnesium, calcium, strontium, alkali solution in the other side. Remember, both streams produce corrosion. Potassium, sodium, all of the elements located here, look, is sodium, is magnesium, is calcium, is potassium, all the alkali. You have two streams, no good. Alkali, acidic, both of them. Remember, those are acidic. Those are alkali. Both streams produce high level of corrosion. This is the composition of the seawater. With that slide, that slide speaks for itself. Yeah, it's highly corrosive. Don't forget, this is important, and don't forget other topic. The salt water is basically minerals and metals. For that reason, salt water is good conductor of electricity, more than fresh water. Fresh water is conductor, but it's not excellent conductor like a salt water. Exactly like the metals. Not all the metals are excellent conductors. Okay, my friends. Yes, at the end of the day, additionally, if you have electricity passing through the metals, the more noble metal attack the less noble. And also without electricity, only because the energy of one metal is superior than the other one, and a small arc of electricity is produced in between, and the more noble attack the less noble. And at the end of the day, the less noble is eroded because release electrons and produce holes. Is eroded. Sacrificial anode. And this is the cathode, the element that absorb electrons. Simple. Yeah? The anode release, the cathode accept, the anode at the end of the day is eroded. Sacrificial anode. You remember the best example in marine application is the copper fittings in aluminum tanks. Oh yeah, at the end of the day, around the copper fitting, that aluminum is eroded. Bingo, finito. This is the situation. Okay. In general, the most common type of corrosion is the general attack corrosion. It's the most common type of corrosion and is produced by the chemical or electrochemical reaction that result in the deterioration of the surface. Yeah, that's regular corrosion. It's also referred to like a general corrosion or uniform corrosion. And yes, it's the metal exposed to the environment. Simple. General attack corrosion, the mechanism of attack typically is an electromechanical process that starts in the surface and goes and goes and goes. Remember that corrosion is the accumulation of oxidation. All the metals exposed to the environment are oxidized. Oh, it's oxidized a little, but it's a little. Okay, it's a little today. But if you check 2 weeks later, it's not oxidized, it's corroded. If you check 3 months later, it's not corroded, it's eroded. And if you check a year later, it's a little piece of metal with a big amount of oxide and metal completely eroded. Yeah, this is the phenomenon. The phenomenon starts with, it's a little oxidized. Be careful with the sprinklers. The sprinklers for water in your home, because that water is raw water. If you live close to the beach, it's brick water. It's a mixture in between fresh water and salt water. And those sprinklers send water over the surface of your car. For that reason, at the beginning, your car is a little yellow. But 1 year exposed every day to that rain will be corroded and destroyed. Okay, be careful with that. This is the general corrosion. There are other corrosion more focused, more localized corrosion. Those are examples of localized corrosion: pitting corrosion, crevice corrosion, and filiform corrosion. 3 different types of focus corrosion: localized corrosion. Pitting corrosion result when a small hole start with a small hole or cavity is formed in the metal. And normally this is because you have a stagnant solution accumulated in a small area for a long period of time and is perforated that area. Don't forget, clean. The second one, crevice corrosion. This type of corrosion is associated with stagnant environment solutions over the surface, or humidity accumulated in between 2 metals. For example, humidity in the head gasket, and you have an aluminum head with an iron block with humidity in between. Yeah, this is other example. Filiform corrosion occur under painted surface when a water breach is like this. When a water breach the coating surface. This is normally when you use unappropriated coating products. Yeah, we are going to study in the next coming chapter the different type of coatings products: organic, inorganic. Oh, be careful if you use organic paint with some alloys. That organic paint accelerates. You need to select the appropriate coating. Oh, it's aluminum. Any type? No, papi, it's aluminum. Be careful. If your hull is in aluminum, you need to check in the label. You need to verify that it's non-copper content. If not, attack the aluminum. Yeah, depending of the material, the coating, the bilge coat, the bottom paint coat should be appropriated. If not, you have filiform corrosion. And additionally, the metal of the case of the case of the appliance. Why that refrigerator is destroyed in my boat? Excuse me, that appliance is a residential appliance? Yes, I think so. The case of that equipment is steel, plain steel, turned plate, regular steel. This is not good for marine environment. Yes, the marine appliance are more expensive. It's because the quality of the materials. It's because the materials for the case, the rivets, the bolts are marine grade. The motor is ignition protected in marine appliance. What is the meaning of that? No electrons jump out when the motor is spinning. And avoid the production of static electricity. Yes, those motors are ignition protected. The wire is marine wire, marine approved wire. The terminals, all of them, they have heat shrink and no humidity penetrate. In residential application, you have that situation with the wires. Those Mickey Mouse terminals in marine applications are not accepted. Now you understand? Oh, why the marine equipments are too? It's because the quality of the materials. It's because the quality of the paint is appropriated. It's because the motors are ignition protected. And additionally, the winding, the copper in the winding is a special copper. Oh no, yes, my friends. For that reason, when you need to rewire the back end of a generator, you need to go to a special place with acknowledged in marine environment, because the wire used in the winding, in the new winding, should be marine grade. It's a lot of things that normally the people, because the people don't know, only say, why it's too expensive. I found it. I have a Merc Cruiser 350. The start motor, this is the same engine like I have in my Chevy Sierra, in my Chevy Suburban, in my Chevy Silverado. And the start motor in the automotive shop is $60, $80. The start motor is equal to the start motor of the Merc Cruiser. It's exactly the same start motor. And the start motor for a Merc Cruiser in a marine shop is $350, $400, $500. It's the same. I put the automotive and the engine is running. Yes, can I check your motor in 2 months? Look at the corrosion over there. And additionally, that start motor, that alternator is not ignition protected. Your boat is gasoline boat. The engine room is closed and your motors are carbureted. In your engine room, you have a lot of gasoline vapor, gasoline fumes. And you have start motors and alternators no marine grade. Okay? It's clear? I hope you be clear with those concepts. Pitting corrosion is like a drill, perforate. Pitting corrosion is where the oxidized surface break down, producing crevice. Simple. Pitting corrosion or crevice corrosion is often in threads, in between surface with dirt and humidity. That's the enemy. That's the enemy. For that reason, I always recommend, before you install the bolt in the block, in the head, in any part, clean the thread. With the wire wheel, clean the thread of the bolt. With air at high pressure, clean the thread on the hull. Yeah, and added appropriated seal on the threads. Loctite, 3M, they produce threads, the seal for those threads. That seal avoid humidity in between the different metals and keep the areas appropriated tight. Pitting corrosion. For example, the correct installation of the anodes is important in order to avoid pitting corrosion. You remember that episode where I showed that the zinc should be separated from the transom? That's critical. That's critical. What happens if that transom is in aluminum and you have a sacrificial anodes in zinc or magnesium, and that metal is in permanent contact with the transom? You have an area is completely eroded around the blocks of metal. For that reason, those sacrificial anodes should be separated. Those sacrificial anodes, in that particular case, the anode of the transoms, are used to drain the static electricity of the equipment internally in the boat connected to the bonding. In this particular case, those pieces of zinc, they don't protect any specific metal. They protect the elements inside of the boat. They drain the current of the elements inside of the boat connected to the bonding. Oh, for the external elements located outside of the boat, you have other things, the external metals outside of the boat. For example, for the shaft, you have those things. For the propeller, you have that zinc. For the rudder, you have that piece of zinc. For the flaps of the twin tabs, stainless steel, you have those things. Yeah? You have specialized things, specialized electrodes, sacrificial anode for the external elements connected in permanent contact with the water. For the elements located inside of the boat connected to the bonding, I have the zincs on the transom. Now it's clear? This is the process, this is the procedure. Crevice corrosion. This form of corrosion is generally associated with the presence of small volumes of a stagnant solution in an interstice, producing crevice, especially in between bolts, when you have rivets. You have humidity accumulated over there. Yeah, my friends, for that reason you need to be analytic in the process of fabrication. In the last chapter of this book, we are going to analyze different type of fabrication process. And we are going to check why you need a special considerations when you put together pieces. Maybe silicone before you put the rivets is better. There are different techniques to avoid the accumulation of humidity in between the elements, in between the parts. And after that, cover with a special resin or with a special coating. There are different techniques. You need to eliminate stagnant solutions. Normally that solution is water, salt water. You need to eliminate dirt, debris, and humidity together. That's catastrophic. This is the enemy. In other words, you need to keep clean the areas. And you need clean the parts before you attach those parts. Okay, filiform corrosion. This is the corrosion in the surface of the elements in between the paint and the metal. Those small like cracks, but it's not cracks. It's like a spider. It's humidity in between the paint and the surface, because the paint is not appropriated, it's organic, and this is regular steel. This is very common in appliance. For example, in the condenser of the air conditioning equipment in your home, that condenser located outside, you have condensers like this in that situation, with a lot of filiform corrosion. Yeah, that corrosion occurs on metallic surface coated with an organic film. Yeah, the thickness is 0.1 millimeters. Normally, the appearance of is fine filaments emanating from one center source, like a spider. Yeah, it's basically because the paint, the coated, is not appropriated for that metal. Be careful with the appliance for your boat. It should be marine appliance. Oh, because it's too expensive. Oh, I prefer the Home Depot. Alright, okay, that's your decision. Oh, I am going to install a good bonding. It's not enough. Those materials, the paint, is not appropriate for marine environment. Yeah, you can install AA groundings, cables. It's not enough. The materials, the coating is not appropriate. Yeah, my friends, you need to be careful with that. Filiform corrosion is a type of corrosion that is commonly known as a localized corrosion, and is normally linked with magnesium alloys, aluminum alloys, with organic coating. Yes, that's the problem. This type of corrosion has a tendency of taking place in conditions with high level of humidity. Areas with nitrates, sulfates, carbonates condensated on the water. Yeah, I explained millions of times in previous episodes about, and this is the situation. This is the appliance. This is a regular residential appliance. Yeah. Galvanic corrosion, that's very common in our environment, occurs when two different metals are together in a corrosive electrolyte, salt water. The galvanic couple forms between the two metals. One of them will be the anode and the other one the cathode. This is the situation that I explained in previous episode. Yeah, the galvanic corrosion. When you have two dissimilar metals together, doesn't matter if you have humidity in between or not. You have one with more energy, other with less energy, and the big one attack the smaller. That's it. Simple. Additionally, I have humidity in between. That process is accelerated. And additionally, I have currents. Finito. That's electrolytic. That process is accelerated faster. Yeah, this is galvanic corrosion. That's the most common. The most common. Yeah, for that reason, you need to protect the metals with sacrificial anodes. Yes, one element will be eroded. It's the sacrificial. I put that one to be eroded. Yeah. Any water contains impurities in the electrolyte. The risk of a galvanic corrosion is reduced when you install the appropriate sacrificial anodes. This is important, especially in hulls, in metallic hulls like aluminum in boats. Yeah, for that reason, the anodes are critical. In the next coming chapter, we are going to analyze the different type of anodes. Yes, my friend, this is a good example. For example, in this particular case, you have the sleeve of the cylinder. The sleeve of the cylinder is an special steel. You remember in our course of diesel, we removed the sleeves, we replaced the sleeves, and those slips are surrounded by the salt water. You remember there are two types of slips, wet and dry. You remember that one? Yes, the wet slips are surrounded by coolant. In those slips is commonly produced pitting corrosion. You remember those slips? Because the people use improper coolant, or use fresh water instead of fresh water is better. No, because the coolant, look at the properties of the coolant: anti-scale, anti-corrosive. Yeah, those additives on the coolant avoid this type of corrosion, pitting corrosion on the slips. And additionally, in the block, you have the block in regular gray iron. You remember? One type of cast iron, gray iron. And here, in between the slip, in good steel, high quality, with regular cast iron. In that neighbor, you have like two dissimilar metal, two dissimilar alloys, and each produced galvanic corrosion. And additionally, in the block and the head, you have the head gasket. If you have humidity in between both of them, what happened? You remember? You remember at the beginning? Crevice corrosion. Yeah? This is a good example. This is a good example. Be careful. You remember when I explained in class the procedure to lap the propellers? The propeller in nibral. You remember? With the shaft. Suppose that you have a special stainless steel shaft, marine grade, but it's steel, and the copper propeller. What happens if you have in between the shaft and the propeller humidity or air in between? That humidity accelerates the galvanic corrosion in between both metals, and one metal, the more noble, attack the less noble, and the less noble at the end of the day is broken. I remember some years ago I was working in a marina in Fort Lauderdale, and I remember one propeller disappeared during the sea trail because the propeller attacked the shaft, was installed for long periods of time with humidity in between. They don't lap appropriated the propeller against the shaft, and the torque produces for the engine and the centrifugal force break, and the propeller goes out, and the shaft was cut. Yeah, it's very common. It's very common in marine application. Be careful with that. This is another great example of galvanic corrosion. We are going to analyze the Galvanic Series like a rule. In this table, you have the typical element that work like a cathodes, and the element that work like an anodes. Look, good anodes are zinc, aluminum, and magnesium. Those three, zinc, aluminum, and magnesium, they are considered good anodes. But cathodes, elements that absorb electrons, platinum, gold, carbon, titanium, those are good cathodes. Elements in the middle, silver, nickel, lead, those elements are in the middle of the Galvanic Series. This is a good table. Try to memorize those elements. Which elements are good anodes? What is the meaning of that? The elements in the bottom at the end of the day will be eroded. In comparison with the other ones on top, the cathodes, they normally absorb electrons. Yeah? This is important when you select the materials and you select the electrolyte. Yeah, for that reason, my friends, the selection of the fittings is critical. I have an aluminum tank, I need aluminum fittings, and I need stainless steel marine grade fittings. Never copper fittings. Doesn't matter if it's a marine grade copper fitting. I prefer if the tank is in aluminum, aluminum fittings or stainless steel Series 300 fittings. Be careful with the fittings. Yes, the environment attack, and also the dynamic of the equipment. There are equipment exposed to constant rotation, constant torque, constant centrifugal force. The material at the end of the day is cracked by stress. Yes, my friends, if you have a piece of metal and you bend it and 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 bend it, suddenly the metal breaks. This is breaking for stress. Like you, like me. You are working every day from 5 a.m. until 10 p.m. No relax, no weekends. Finally, one day you are finito. You need relax one day per week. Disconnected. Exactly the same with the metals. If you expose the metal to cycling, suddenly it's broken. Environmental cracking is a corrosion process that can result from a combination of environmental conditions affecting the metal. For example, chemical conditions, temperature conditions, and stress related with conditions that produce those type of fractures. Stress corrosion, stress corrosion cracking, SCC, corrosion fatigue, exactly the same like the people, hydrogen-induced cracking, and liquid metal embrittlement. We are going to check what is the meaning of that. Stress in the metal, yes, my friends. Stress corrosion cracking is the cracking induced from the combination of tensile strength and corrosive environment. Stress corrosion is the combination of tensile strength and corrosive environment. Tensile, there are tensile, compression, and torsion. Once again, tensile, you tense, compression, you compress, or torsion, you torque. Ready? Those are three types of stress: tensile, compression, and shear or torque. The impact of SCC on a material usually falls between dry cracking and fatigue cracking. Yeah, fatigue in the metal is incredible, no? Because the metal is exposed to cycling effort. This is the example. What is the meaning of that? Small cracks are propagated because the cycling movement of the metal produce stress, and the stress propagate a crack. In aircraft, is very common. For that reason, in aircraft, one of the rules is no corners. Everything is rounded to avoid concentration of stress in those corners. For example, the windows on the airplanes. Some years ago, the windows are square, and they discovered that on that corners, the crack is propagated. And right now, in airplanes, they are oval windows or circular windows in order to avoid the propagation. The windows for the gas, they are ovals to avoid that concentration of stress in those corners. This is very common. Yeah, corrosion fatigue. Yes, it's a fatigue in a corrosive environment. It's the mechanical degradation of the material. Yeah, because the corrosion and the cycling load, like I explained before. Yes, it's very common, but if you check at the end of the day, all of those names of corrosion, filiform corrosion, stagnant corrosion, crevice, it's the same. It's humidity, dirt, in a marine environment, with currents passing through the, exactly the same. With different names, but it's the same. Corrosion is corrosion. Finito. I need to avoid that. Keep your boat clean. Number 1. Select appropriate materials. Number 2. Connect everything to the bonding. Number 3. Install anodes in appropriate parts. Number 4. And install good gauge and meters, especially and meters, digitals, to verify if you have leaks. And suddenly, twice per year, with the silver chlorine electrode, check the condition of the water and your boat in that specific marina or in that dock. Use the electrode to verify if your bonding is appropriate. Finito. This is the rule. That's the information that you need. No more. I recommend try to write a good log book in order to copy the result of the electrode and verify and try to do the comparison with a year before, 2 years before, and today. And install gauge and meters. I have meters analog, but the needle move a little. You need digitals, because in digitals you can verify. Remember, you need more than 0.001. With the needle gauge, it's impossible. You need a digital. For that reason, in the demonstration, I put my digital multimeter, because with the digital you can read. Install digitals in the AC and DC panel, additional to the other ones. You are doctors. I explained in other episodes how to install an ammeter and how to read the ammeters. It's the same procedure. Yes, this is very, very, very important. The fatigue, corrosion fatigue. Yes, much lower failure stress and much short failure times can occur in a corrosive environment in comparison with the regular environment. Is metal exposed to cycling load? One day it's broke. Simple. Hydrogen-induced cracking. We are going to try to translate in Christian words. Is the free hydrogen in the water that attack the surface of the metal. Remember this, my friends. What is the atomic number of a hydrogen? You remember? Hydrogen is here with only one electron in the last orbit. Yeah, and this is excellent for elements in the group number 7, because those elements in the group number 7, they only need one extra electron to be stable. However, when you combine hydrogen with the fluorine, with chlorine, with bromine, you produce acids. Remember, one of the conditions for acid is contain hydrogen, except water and methane, you remember. Okay, hydrogen in combination with those nonmetals of the group number 7 produce acid, chlorhydric acid, fluorhydric acid. And those acids are acid, and the acid attack. Yeah, for that reason, when you have a free hydrogen in the environment, that free hydrogen combined with the chlorine of the salt water produce acid, and those acids attack the metals and accelerate the corrosion. Simple. How can I get free hydrogen? When you apply improperly paints in the surface of your material, in the surface of your hull. No, I paint the hole with the paint that I have in the storage of my home, and now the hole looks nice. Yeah, looks nice, but this is not appropriate for marine environment. You want to put the boat tomorrow on the water? Yes, tomorrow morning I'm going to put the boat. Oh, baby, that coating will be catastrophic for your boat. This is organic, it's not marine approved. No, the color, yeah, the color is nice, but this is not a bottom paint, and it's not appropriate with that hole in aluminum. That paint, as soon as you introduce the boat on the water, the hydrogen will be free, combined with the chlorine and fluorine of the salt water, produce acid, and that acid destroys the hull of your boat. Bingo! You like the explanation? It's simple. You need to be analytic. You need to try to understand what happened in my boat. How can I protect my boat? How can I avoid those alloys, those environments? Metallic storage tanks are a good example of hydrogen-induced cracking. Typically, failures occur when storage tanks, roofs saturated with hydrogen, and the hydrogen in combination with the humidity produce the acid and attack the surface and destroy it. Yeah, this is a good example. Normally in a exhaust pipes of a dry exhaust pipe system. You remember in our course of diesel in the keel cooling systems, the advantage of the keel cooling system is that you don't have raw water inside of the boat. In that case, the smoke is dry smoke, and you can use regular exhaust pipe. Be careful with the material of those regular exhaust pipes, because it should be marine grade. If not, you have that type of corrosion, induced hydrogen cracking. Okay, flow assisted corrosion or flow accelerated corrosion result when a protective layer of oxide of metal is solved on the water, exposing the metal to further corrosion. All of them are exactly the same, and you repeat and repeat and repeat. It's stress, it's marine environment with the improper material. All of them are the same. The secret is select the appropriate materials. No, that the exhaust pipe of a truck, Caterpillar truck, good truck, yes, papi, but it's not for marine environment. No, because I am going, no. That material is not, that steel is not appropriate for this environment. And there are millions of the appliance. Oh, it's a good appliance, it's General Electric. Yes, my friend. All of this is true. But the material is not appropriate for the marine environment. Oh, no, my friend. No. Freezing corrosion occurs as a result of a repeat wearing weight vibration on the surface, producing beading corrosion on the surface. Freezing corrosion is often found in a rotation machinery. Yeah. Stress. Torque with a centrifugal force produces stress and crack. I hope you enjoy this wonderful chapter.